Welcome to the session on operations management. In this session, we will discuss a quantitative type of forecasting method, which we commonly call as linear regression. And we'll see how this linear regression method is used in forecasting. So the topic for this session is linear regression as a forecasting method. Linear regression. It is a model that uses least squares method to identify the relationship between a dependent variable and one or more independent variables that are present in a set of historical observations. You have seen quantitative methods use historical observations to predict future. So linear regression is a type of quantitative method. Linear regression is a type of quantitative forecasting method because it uses historical observations. In simple regression, there is only one independent variable. In multiple regression, there is more than one independent variable. Linear regression is ordinarily used in long-range forecasting, though it can be used in short-term also. If care is taken in selecting the number of periods included in the historical data, and that data is projected only for a few periods into future, regression may also be appropriately used in short-range forecasting. For example, 12 months, that is 1 year, can be divided into, say, 4 quarters, that is 4 quarters. So first 3 months, first quarter, second 3 months, second quarter, third 3 months could be the third quarter, and the fourth 3 months could be the fourth quarter. So you can even apply linear regression in short range forecasting. Variable definitions and formulas for simple linear regression analysis. X here is the independent variable value. Y is the dependent variable. Y depends on X. N is the number of observations. A is the vertical axis intercept. B is the slope of the regression line. Now these are the different formulas for simple linear regression analysis. Any simple linear regression analysis will make use of these variables, and this nomenclature will be utilized, this particular representation will be utilized and substituted in the equation given below. Vertical axis intercept small a is equal to sigma x square into sigma y minus sigma x into sigma xy whole divided by n sigma x square minus sigma x whole square. The slope of the regression line b is equal to n into sigma xy minus sigma x into sigma y divided by n into sigma x square minus sigma x whole square. So these equations need to be understood, and when we solve a problem, an example in the subsequent slide, we will be using this equation again to find the regression line. The regression line is given by capital Y is equal to A plus B into capital X. Capital Y here refers to the values of Y that lie on the trend line, and capital X refers to all the values of X that lie on the trend line. We introduce a new term now, indicated by small r, which is the coefficient of correlation. R is n into sigma xy minus sigma x into sigma y divided by square root of n into sigma x square minus sigma x whole square into n into sigma y square minus sigma y whole square. Again I repeat, R is equal to n into sigma xy minus sigma x into sigma y divided by square root of n into sigma x square minus sigma x whole square into n into sigma y square minus sigma y whole square. What is this coefficient of correlation? The coefficient of correlation R explains the relative importance of the relationship between y and x. We need to know what is the relationship. Are they strongly related or are they very weak? The relationship is very weak. So coefficient of correlation R will explain whether y and x are strongly related or weakly related. The sign of R shows the direction of the relationship. The sign of R, the R value which you get after you substitute the above formula, the value that you get, the sign of that, whether it is a positive value or a negative value, will show you the direction of the relationship, that is the direction of relationship between x and y. The absolute value of R will show the strength of the relationship. Now the sign of R will show the direction of the relationship, that is if x increases, does y also increase or does y decrease on increase of x. So that is the sign, that is the direction of the relationship. What is this absolute value? Absolute value of R. R might be positive or negative, but the absolute value of R will show the strength of the relationship. We will come to know when we discuss the following points. R can take any value between minus 1 and plus 1. So R can take any value between 1 and minus 1. The range for the value of R is between minus 1 and plus 1. It can be minus 1 or plus 1 or any value between minus 1 and plus 1. A negative value of R indicates the values of y and x. So this is the negative value, the sign of R. Negative R, that negative value of R indicates, or negative R indicates the values of y and x tend to move in opposite direction. That is, when y increases, x decreases, or vice versa. Whereas a positive R indicates the value of y and x move in the same direction. So a negative value means y and x tend to move in opposite directions, whereas a positive R indicates that the value of y and x move in the same direction. Now the absolute value of R, if I said, you have seen here already, R can take any value between minus 1 and plus 1. So a value of plus 1 here represents R is equal to plus 1, means a very strong relationship, very high relationship, which means x and y move in the same direction and also the strength of the relationship is very high. Minus 1 means again the value of 1 means very strong, but then the direction is different. Even though the strength is strong, but the direction is different, which means as x moves upwards or x increases, y will decrease. A negative value means as x increases, y will decrease. So minus sign represents the direction of x and y is different. Plus represents x and y move in the same direction. Absolute value, that is the value of 1 or 0.5, etc., they will reflect the strength of the relationship. They will reflect the strength of the relationship. A value of 0, R is equal to 0, means there is no relation, there is no relationship at all. When R is equal to 0, it means there is no relationship at all. So once again, please note, a value of minus 1 means a perfect negative relationship, that is, as y goes up, x goes down. Plus 1, a perfect positive relationship, as y goes up, x goes up. R value of 0, no relationship exists between y and x. I say plus 0.1 or 0.05, R value of plus 0.05, just an example, plus 0.1, a very weak positive relationship. Similarly, minus 0.9, a strong negative relationship. Hope you have understood. So please take into mind, absolute value of R shows the strength of the relationship, whereas the sign of the R shows the direction of the relationship. Let us take an example. A company produces commercial water filters that are sold throughout the country. The company's plant manager thinks that the sales growth will continue, and he wants to develop long-range forecasts to help plan facility requirements for the next 3 years. Sales records for the past 10 years have been compiled. So this is a problem, or this is a case which we'll study now. A company produces commercial water filters which are sold throughout the country. The plant manager wants to estimate the forecast for the next 3 years. Sales records are there. For the past 10 years, the sales records are given. It's given in this table. You can see here first 5 years, then from year 6, 7, 8, 9, 10. Annual sales in thousands of units is given. First year 1000 units, again 1000 in thousands. So whatever values are given here are in thousands. So you can see here 10 years data is given. 10 years data is given. The company, the plant manager wants to make an estimation or a forecast for the next 3 years. So let us see how we proceed. Yes, see here, annual sales are given here. The annual sales in thousands of unit. Now this is the y value. This is the y value. What is asked? The forecast for the next 3 years. So this is the year which are listed here as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That becomes the time period becomes x now. Time period now becomes x, correct? And y is the sales. So what is required now for the next 3 years? That is for values of x is equal to 11, x is equal to 12, and x equal to 13. We need to now find out what are the annual sales y values. So these annual sales values are y, time period is x. Now these are what we have calculated. This is given, this particular column what is written here, and this year 1 first column, second column data is given. All others are listed by us. Here you can see here 1000 units is the annual sales. Now the time period for the first variable x is 1 here. So 1 first period 1000 units, second 1300, 10 years data. I need to now find out, or the plant manager now wants to find out the data, the forecast for 11, 12 and 13. 11, 12 and 13. What is the required data that we require now? We require sigma y here, the expression which I showed you to find a and b values. First we have to find the a and b values and then substitute that in the trend line equation. First we have to generate a regression line equation. A regression equation has to be generated first. For that we need to have a and b values. So that is why we are now finding out this. First make sigma y, find out sigma y, add all this, summation of all these values. Sigma y is 21,000, summation of all x values, sigma x is 55, x square, 1 square, 1 square, 2 square, so on. The square of these particular values are written here, respective values. Sigma x square is 385, and this column gives you the product of this x and y. 1000 into 1 is 1000, 1300 into 2 is 2600, and so on for all the values. 3200 into 10 is equal to 32,000, and so on. So sigma xy is 1,33,300. So this is how you prepare the table before you start the regression. Now based on the value given, note down these values. Sigma y is 21,000, sigma x is 55, sigma x square is 385, and sigma xy is 1,33,300. Next, so in the next table, now that previous table values were enough for you to find a and b. This is the next table. In this table, it's the same table, all these values are same, but I've added another value, y square. Now this is required for finding out r value, coefficient of, or the coefficient, or the coefficient of correlation. R value, coefficient of correlation coefficient or coefficient of correlation value. For that we require y square value also. So in the same table you can add y square, or you can make a separate table. You can, in the same table also you can make y square values and write. So these are the different y square values. Y value is given here, the square of that, and the summation of that is given sigma y square. The value is written here. Now x is the independent variable value, y is the dependent variable, n is the number of observations, a is the vertical axis intercept, b is the slope of the regression line, and these are the values which we have written here. What is n value here? N value is 10, because the number of given data is 10. For 10 years observations are given, the number of observations is 10. So in the equation which you have already seen, the same equation for a which you have seen in the previous slides, I substitute all the values and I get a value of 913.33. So when I substitute the values in the equation for A, which is the vertical axis intercept, I get 913.333. 913.333. And similarly B, when I substitute it in equation for the slope, I get a value of 215.758. 215.758. So A value and B values, both the values I have got by substituting these values from the previous table in the standard formula for A and B. So this is how I get the vertical axis intercept and slope of the regression line. So A and B values are already got, and now what is the next step? We need to now generate or find out or make a regression line, which will be, this is a solution for it. We'll see how the regression line is generated. The regression equation will be y, capital Y is equal to a plus bx. So y value we have got 913.333, that is A is 913.333, B is 215.758. So when I substitute that, see here, A value I have got as 913.333, B is 215.758. So the sales forecast in thousands of units for the next 3 years. So we have already seen. So any year's sales can be now forecast based on this 10 years data that is given. So here if I have to find Y11 for the 11th year, till 10 years data is given. So Y11 will be, this will be a constant 913.333. This B slope is also constant. What will change is only this X value. This value will change. So I will substitute 11, 12 and 13 here. So I will be substituting 11, 12 and 13 here, and I will get these units: 3286.7, 3502.4, 3718.2 units. So are these values Y11, Y12, Y13. So these will be the forecasts for the 11th year, 12th year and the 13th year. So this will be the forecasts for the 11th, 12th and 13th years. So this will be the forecast. So this is how we will calculate the forecast for any years which we need to forecast. So now suppose even one more 14th year was also given, then Y14 would have been 913.333 plus 215.758 into 14, whatever value you get. So these units of air coolers are the forecast values. These are the forecast values. So that is why Y is the dependent variable. Y is dependent on X. As X changes, Y also changes. As X changes, Y also will change. That is why Y is the, that is why we call Y as the Y is the dependent variable. Y is a dependent variable and X is the independent variable. Y is the dependent, depends on X. Y is the dependent variable because Y depends on X. X is independent. X does not depend. What is actuals is substituted as X. Correct? Y is dependent. Y is dependent on X. So Y is the dependent variable. X is the independent variable. So next step is to now find out the coefficient of correlation R. Now I have already got the Y values based on the given set of X values. Now I need to find the correlation coefficient. So when I substitute this in the equation given, I get a R value of 0.97. I get a value of R is 0.97, which means it's a positive value. So what does it mean? We have already seen R is equal to positive plus 0.97, which means it's a positive value, which means both x and y move in the same direction. As x increases, y also increases so far consistently. So it's a very strong positive relationship. It's a very strong positive relationship because it's plus 0.97 and 0.97 is very near to 1. So a very positive, the relationship between x and y is almost perfect. If it was 1, it was almost perfect, very close to perfection. But yeah, and it's very close to perfection. It's a very good, very strong relationship and a positive relationship. As x increases, y also increases, and also the strength is very positive, almost perfect. So the coefficient of correlation is strongly positive, which indicates that the values of y and x move in the same direction. So this is how the regression analysis is done. So we will be now again, as it was discussed previously, even for short term, sometimes if the number of time horizons is very less, we can apply this particular method, but usually it is applied for long term. Usually it is applied for very long term forecasting. Now let us see what would happen if the data changes now. If some of the forecasts that were given, the actual for the x values change, then the entire dynamics, the entire value of y will also change, because y is dependent on x. So when x value changes, y value will also change. So that is why y is dependent on x. Y is dependent on x. So please keep that in mind.